the hard thing on this is people really want. So, someone got a message. All right. So I was supposed to have given you. I was supposed to have assigned you page 143, and I didn't. I assigned you, I think, 116, which we did last week. I apologize. So, let's take a look at some of these. I can run through them relatively quickly. So problem number 1 on this page says f plus g at 5, and they tell you that function at x is equal to x squared minus 3, and they tell you that g at x is equal to 2x plus 1. What do you think? What should we do with this? What am I substituting in for x? 5. So this problem here, if I plugged 5 in, that's going to be 25 minus 3, which is 22. This is going to give me 2 times 5, which is 10, plus 1, which is 11. What are we doing with the 2? Adding. Done. Okay. Man, you gave us an easy assignment. You goofed it up. Yes, I did. Sorry. All right. So problem number 2, number 3, number 4, number 5 are all done the exact same way, all the way through number 10, which I was supposed to have given you. And then 11 through 16 are going to be done the same way. So if you had something like this saying, hey, you're going to either add them, you're going to subtract them, you're going to multiply them, you're going to divide them, but you're plugging a number in, plug the number into each of the equations, and then do what it's asked above. So if this was, fg of 5, that means you are multiplying them together, which means you would have went 22 times 11, which is 242 for an answer. Okay? And I apologize again that I goofed it up, so obviously I will not be collecting an assignment that I had already assigned. 17 through 29 we also gave. Okay, so then after that, let's take a look at number 19 would be a problem that I would have assigned you. So problem number 19 says we have the function at x is equal to x minus 3. G at x is equal to the square root of x plus 4. They want you to do the following. Find the domain of both. Find the domain of both. And then find f plus g. Find, that'll be the first one we'll do. Okay? All right. What is the domain of this one? What's the domain? What's the domain of the red one? Anything I can plug in? Anything that make it not work? Negative, positive, infinity. Okay? So negative to positive infinity is my domain of this one. What about the second one? So what about negative 4? Is it only negative 4 or is there more numbers than that? Anything but negative 4? Or lower. Can negative 4 or lower? So let's think about this. If I plug negative 4 in, I get negative 4 plus 4, which is 0. What's the square root of 0? 0. Negative 4 is going to work. What about if I plug negative 5 in? Negative 5 plus 4 is negative 1 squared to negative 1. For those of you who remember back, it's I, but we're trying to get real numbers, not imaginary. So can I plug negative 4 in? Can I plug anything smaller than negative 4 in? So negative 4 to what is going to work? Infinity. Okay? So there's the domain of that. Okay, if I add, subtract, multiply, divide, substitute in, anything like that, no matter what function I do with this, my domain has to be that restricted or more. Okay? Meaning, I can't do a mathematical function to this problem, and then all of a sudden, the domain, once you do the math function, goes from negative to positive infinity. Okay? You find your original domain. Your original domain has to be as restricted, if not more, for your answer. So if I were to add those two together, I would just get x minus 3 plus this. So my domain has to be as restricted as the most restricted domain. If I subtracted them, same idea. If I multiplied them, same idea. If I divided them, if I wanted this, this is going to be x minus 3 over the square root of x plus 4. Is the domain square bracket negative 4 to infinity? If I plug negative 4 in to the denominator, what do I get out? 0. So what can you tell me about the negative 4? Is it square bracket or round bracket? Round bracket. So the domain of f over g in this particular one is going to be round bracket, negative 4 to infinity. Is this a tighter or more restricted domain than the original? Why is it more restricted? You're absolutely right. Why? Yeah, you're losing that one extra number. Okay, the square bracket means you include the negative 4, go to infinity. The rounded bracket says, hey, you're starting just above negative 4, not at negative 4 exactly, and go to infinity. So the new domain of the new function down here is more restricted. That's more restricted than that. Okay, and that's fine to do. It just can't be less restricted. We all right? Okay. You guys ready for the lecture? I gave you the wrong assignment, so I just kind of went over it a little bit. Okay. We're going to be talking about composition of a function. And this will go along within the blue book, I believe. If you want to do it on here, or you can do or we can do it as regular notes in a notebook, or it's your choice. Cool? So, I'm going to miss a Monday here in a couple weeks, and I think my boss will actually be just teaching this class. He's a nice man. His name's Jay Moore. So he'll come in and run through some stuff. So as a new math teacher to the district, they invited all new math teachers to the district to some wonderful extravaganza, which I'll learn so much at. I'm excited about it. All right. You might be able to detect a little bit of sarcasm in my voice. I apologize for that. Good. I did my job well. This is page 22, I believe. But I might be goofed up. But at the very top it says composition of function putting one function into another. Page 26. Page 26 looks like. Okay, here we go. If you're talking, you're being rude. If you're talking, you're being rude. Okay, so I believe it's on page 26 in your blue notebooks. Might be page 22 if you got one at the top of the pile. So the first thing on there talks about composition of functions, putting one function into another. Says let function at x equal 2x minus 5. Let g at x equal x squared minus 4x squared plus 5. And then what we want to find is we want to find something called f g at x And then next to FG at X, they have this. Looks like it says the word fog. Okay? Both terminologies mean the exact same thing. Why is there a difference between the two? Who knows? Okay? Ryan Griggs here.
Yep.
Sarah McGuire here. Sarah's not here. All right. So I want to take one function and plug it into the other. Take one function and plug it into the other. So I'm going to take this, g at x, which is right here, and I want to substitute it in right there. So this means I'm going to take 2 parentheses. There was an x there. I'm going to take a whole other function and plug it in. So I'm going to plug this in right here. Distribute over the parentheses. So you get 2x squared minus 8x plus 10 minus 5. Like terms would be the 10 and the negative 5, so I'm going to get 2x squared minus 8x plus 5. There's my answer. I plugged one function into another. Is that all right so far? Should be at the bottom, I believe. You have FG at X at the bottom, 26. The other way says we want to do gf at x. We want to do gf at x, which they say is, looks like GOF. This is like the circle, it's not necessarily an O. Which this means that I'm going to take this function here and I'm going to plug it into all the x's. So I have this squared minus 4 parentheses plus 5. I'm going to take the, rather than have an x, I'm going to plug 2x minus 5 in. And then do the math. Okay? The math here is 2x minus 5 times 2x minus 5. This one I just distribute. I get negative 8x plus 20 plus 5. What 4-letter F word takes place there? FOIL. Good. Thanks for saying that one. So I'm going to get 4x squared minus 10x plus 25 minus 8x plus 25. So I combine some of the like terms. There are some others. I don't have any other x squared, so I'm going to get 4x squared. That's taken care of. Combine the 10x, that's minus 20x, minus 8x, negative 28x. The 25 and the 25 added together gives me 50. There's the answer. Is that okay? And then there's a portion that says, hey, we would like to know what FG at 7 is equal to. Thoughts? Thoughts there? Yeah, absolutely. So I'm going to plug 7 in here and here, so that's going to give me, 49 minus 28 plus 5. Did I do that right? 7 squared is 49. Negative 4 times 7 is negative 28 plus 5. Do the arithmetic. So 49 minus 28 is 21. Add that to 5, which is 26. What am I going to do with 26 now? Plug it into f of x. So now I have 26. So I did my inner first. Found that's going to be 26. So this is now going to become function at 26. Why is it function at 26? Because g at 7 is equal to 26. So now I'm going to take 26 and I'm going to plug it in for this. So I'm going to get 2 times 26 minus 5. 2 times 26 is 52. I'm going to subtract 5 from that. So I'm going to get 47. okay with that so far? All right, we practice this one real quick. There's a practice that's in the book. They want us to do try that. Try that one, see if you can figure it out. The far right board. So careful. Nope. Perfect. Nope. So we FOIL that off first. Once you're done, distribute 3 to that place. And then divide it. That's where I started with this. Most of you, as I walk around, look like you have that. FOIL the 5x plus 2. Distributed 3. Yeah. Perfect. I think that's right. All right. Here we go. What did I get? So that's a little bit of work being done with it. FOIL this. Is that okay? So if I combine those together, I get 20. Is that correct? Combine that together, I get 20. So that's going to be 75x squared plus 60x plus 12 minus 20x minus 15. I do that right? Combine any like terms, 75x squared by itself. Plus 40x.
Would you get 15? 15, yeah, would you get 15? That's 4 minus 7 out of 8, right?
So did you go negative 4 times that to get negative 8? Yeah. Negative 8 minus 7, right? That's okay. I think I'm almost done. Let's see, minus 3. I think that's the answer. 75x squared plus 40x minus 3. Does that look like the answer works? Seem okay? All right. Question for you. What is the domain of f at x, the original? What's the domain of the original? What's this domain? Negative and positive infinity. Love it. What is the domain of this one? Negative and positive infinity. As you look at that right now, does there seem to be any restrictions on the domains of the two going into the... Any restrictions on any of the domains? No? What do you think the domain of this is going to be then? Yeah. Now, could there have been a restriction on this? Yeah. If you had a denominator with an x in it, if you had a square root that had an x in it, things like that is where there might become a restriction. This happens to not have any restrictions on the problem. Seem okay? Yes, sir. Wait for the camera on the way by. All right. I think you guys are ready to rock and roll. So I want to give you the opportunity to work on this. Looks like we have quite a bit of time left in class, so use it for your advantage, not as your social. So page 143, 1 through 16 all, 17 through 29, every other odd. If you don't know how to do every other odd, just do all the odds, you get it right.